Good afternoon, everybody. My name is Sean Patchett, and today I'm going to be your instructor. Today's lesson is going to be on thunderstorms. This lesson will introduce thunderstorms and the hazards they impose to aircraft. An overview is we're going to be talking about the conditions necessary for formation of a thunderstorm, the life cycle of a thunderstorm, and avoidance procedures. So some hazards that an aircraft can encounter while flying are turbulence, wind shear, microbursts, hail, and lightning. If there was a single storm that encompassed all of these hazards, would you want to fly anywhere near it? Thunderstorms create the single greatest hazard to aircraft. Understanding the characteristics of these storms and the hazards they impose is essential to all pilots. You must be able to recognize when the meteorological conditions are conducive for formation of a thunderstorm, and you must also know what to do if you encounter a thunderstorm along your route of flight. So we're going to get started with the conditions necessary for formation of a thunderstorm. The first one we're going to talk about is an unstable atmosphere. What that means is basically the temperature is going to decrease rapidly with altitude, and also the environmental lapse rate is going to be greater than the lapse rate of the parcel of air, the warm parcel of air that's rising. So what that means is, say you have 1,000 feet and 2,000 feet here. You have a parcel of air, let's say it's 10 degrees Celsius, and its lapse rate is standard 2 degrees per 1,000 feet. We'll say the ambient air around it is 8 degrees Celsius, and it's dropping at, we'll say 4 degrees Celsius per 1,000 feet. So if you come up here to 2,000, this is now going to be 8 degrees and 4 degrees. So as long as that ambient temperature stays below the temperature of the parcel, it's going to allow for it to continue to rise as it is warmer and less dense. Second, we have lifting action. Some lifting action is required. So, say that's a surface. There's 3 types. First one is orographic. So crude drawing, but we'll say that's a mountain range there. Basically, as wind flows into it, it just gets pushed up the slope and up into the atmosphere. So that's orographic lifting. Next you have just convective lifting. You get heating, the surface heats up, it warms that surface air up, and it just begins to rise. And third, we have frontal lifting. So we have, say that's a cold front and a warm front. This cold front is advancing on that warm front. That cold front's going to move under the warm front because it's colder, more dense air. It's going to basically just shoot that warm front up into the atmosphere. So we have orographic, convective, and frontal lifting. And third is we need relatively high moisture content or high relative humidity. So for review for the conditions is what 3 conditions are necessary for a thunderstorm to form, describe an unstable atmosphere, and list the 3 types of lifting action. Alright. Next we're going to talk about the life cycle of a thunderstorm. So basically how any cloud forms is basically you need 3 things. You need water vapor, you need air cooling to the dew point, and you need condensation nuclei. So just keep that in mind. There's 3 stages to a thunderstorm. we're going to talk about each one individually as we go along. So the first stage is the cumulus stage. The cumulus stage is predominantly composed of updrafts. These updrafts provide the lifting action. The air is going to cool to the dew point, and at that point water vapor condenses into small water droplets or ice particles. And basically what happens if there's a sufficient enough amount of moisture is that water vapor condenses, it releases what's known as latent heat energy. And basically how that happens is when water vapor, as water evaporates, it stores heat energy inside of it, and as it condenses, it releases that heat energy into the atmosphere, the air surrounding it, and it basically heats up that air surrounding it. And so if you have a high moisture content inside of this cell, and you have a lot of that condensation happening, you're getting a lot of that latent heat energy released into the atmosphere, or into that storm, and that basically only enhances the ability for vertical development, because it just creates a less dense environment there. So you can get updrafts of up to 3,000 feet per minute, and basically this is how the towering cumulus clouds are then formed. With these strong updrafts, it basically keeps all the precipitation or all the moisture inside of the cloud. Those small water droplets that have been formed from the condensing are too light to fall through the updrafts. So there's basically a circular path here. Say this is your thunderstorm. You got all these small water droplets, but you got all these really strong updrafts. So they'll come up, and they'll fall, and then they'll come back up, and as they circulate through that storm, they just keep the cycle going, and they coalesce with each other. They smash into each other, and they condense, or they coalesce, and they form bigger droplets as they go through this cycle. So basically that's the cumulus stage. A review for that is: what is the first stage of a thunderstorm? What is released as water vapor condenses? What effect does this have on the formation of a thunderstorm? And what happens to the water droplets in the storm during the cumulus stage? The second stage is the mature stage. Basically, after about 15 minutes of the cumulus stage, the mature stage will take place. Basically, what happens is those droplets going through that cycle of rising and falling within that storm begin to grow larger and larger. So as they're coming around and they're smashing into each other, they get bigger, bigger. And basically what happens is you get bigger and bigger drops, and they're going to get too large for those updrafts to sustain them or support them, and they're going to just continue. They're going to start falling out of the clouds basically as precipitation, and that basically signifies the mature stage of the thunderstorm. And what happens is that as these these water drops start to fall, they create friction and drag, or they create friction on the air surrounding them and pulls the air down with them, and that essentially starts creating downdrafts within the thunderstorm. And since you have so much water content and so much rain, so much precipitation falling, it's pulling a lot of air down with it, and you get these really strong downdrafts that can reach up to 2,500 feet per minute. And as these downdrafts hit the ground, they start diverging, and since they're falling so fast that the air doesn't have time to warm up, so one thing you will notice is a sharp decrease in air temperature Another thing is you'll get a rise in pressure, so you get that colder air on the surface, and also that downward movement of the downdrafts is kind of compressing the atmosphere, so you'll get a rise in pressure from that. You'll also get strong, gusty surface winds and turbulence. Clean this up a little bit. So another thing is you'll get your updrafts here, downdrafts. What you'll get right here is basically the leading edge of your downdrafts. This is basically known as your gust front. And what that happens is that this is basically the most forward part of your downdrafts coming out of the storm, and then you just have your ambient air here. Well, what that basically creates is a shear zone, a wind shear zone. And this can actually extend out quite a ways from the thunderstorm. It doesn't have to be contained right underneath it. And what happens here is with this shear zone and this ambient air temperature, it kind of, since you have that downward force of the downdrafts, it basically creates kind of a roll cloud here on the lower leading edge of that thunderstorm there. So basically, the more water you get, the more water drops that fall out of it. Creates more and more downdrafts. The downdrafts are going to begin to spread out throughout the whole storm, and that's basically going to start weakening all the updrafts. Basically, the storm needs those updrafts to sustain itself, so the whole storm system then weakens. So review is, what is the second stage of a thunderstorm? What signifies the beginning of the mature stage? What happens inside the storm as rain begins to fall? What things occur as a result of the downdrafts reaching the surface? And what causes the storm to weaken? Alright. Third stage is the dissipating stage. Basically, this is pretty much all going to be downdrafts, lots of precipitation, and the storm is basically that precipitation falling. It's basically the storm falling. It's basically just diminishing itself or dissipating. One significant thing that happens though is basically at this stage the storm has reached its total vertical height, or its maximum vertical height, and it'll reach these upper level winds, which will kind of start blowing the top out, and you'll get that anvil shape. And this happens in the dissipating stage. So not a lot happens. It's basically the storm's just completely weakened. There's hardly any more updrafts. It's pretty much all downdrafts, and it's raining itself out basically. So review is, what is the third stage of a thunderstorm? What is the main characteristic of the dissipating stage? And what significant event happens to the storm aesthetically? Excuse me. Alright. I think that's going to conclude our lesson today. We talked about the conditions. Wait, I'm sorry. One more. Thunderstorm avoidance. Follow my cycle there. Alright, so we have avoidance. Basically, when you have a thunderstorm, you want to circumnavigate the thunderstorm. You never want to fly right through it. You always want to fly around it. Hail and severe turbulence can occur well outside of a thunderstorm. Those downdrafts dissipating, they can be very strong, 2,500, 3,000 feet per minute. It's going to travel ways. It's going to travel faster than the storm is. So that kind of stuff can be encountered, a good distance away from the storm. So, a good standard that we use is 20 nautical mile distance from any thunderstorm out there. So, 20 nautical miles, stay away. And that is going to include my presentation for today. So we covered the conditions necessary for formation. We covered the 3 life cycles of a thunderstorm. And we talked a little bit about avoidance procedures. Thank you very much.